Hello friends, welcome to my channel. In today's video I am going to discuss about condition for constructive and destructive interference. As you can see in the figure, here I have drawn two slits. This is my first slit and this is my second slit. Two waves are coming, one from first slit, say S1, and another from this slit, say S2. And these waves are interfering on the screen. Say this is my screen. Say the wave which is coming from S1 be given by the relation A sine omega t minus kx. Let the amplitude of the wave be A1, circular frequency be omega. Okay. Let there be second wave coming from S2 and let it be represented by A2 sine omega t minus kx plus phi. Now here I have tried to show that phi is the phase difference between the first wave and the second wave. Now these waves are trying to interfere on the screen. So if these two waves interfere, the equation of the resultant wave will be given by y equals to y1 plus y2. So let us proceed to add these two equations. A1 sine omega t minus kx plus A2 sine omega t minus kx plus phi. Now A1 sine omega t minus kx plus A2. Let me expand this. Sine omega t minus kx plus phi, I am expanding it. Sine omega t minus kx cos phi plus cos omega t minus kx sin phi. Now here, as you can see, I will try to take sine omega 2 common, sine omega t minus kx common from these two terms. So let's proceed to do it. Say sine omega t minus kx A1 plus A2 cos phi plus A2 cos omega t minus kx sin phi. So this is my equation. Further I can do little bit of reshuffling. Say A1 plus A2 cos phi, I am writing first sin omega t minus kx, and here I am writing A2 sin phi first, and then I am writing cos omega t minus kx. Now here let A1 plus A2 cos phi be given by r cos theta. I want to reduce this equation, so I am introducing these things. A2 sin phi, at the same time let me choose this term A2 sin phi as r sin theta, and then I will substitute here and here. Let's do it. So my equation will be reduced to r cos theta sin omega t minus kx plus r sin theta cos omega t minus kx. If you analyze further, this equation which I have got, it can be reduced to this term r sin omega t minus kx plus phi. You can see carefully. Now again, since I have reduced this expression to this, I have to find the value of r in terms of these given parameters. So what I will do is, let me name this as equation 1 and let me name this as equation 2. In order to find out r, I will equate equation, I will square and add equation 1 and 2. So if I square, you can see r square cos square theta is A1 square plus A2 square plus 2a1 a2 cos phi. Similarly, if I square and add equation 2, I get r square sine square theta a2 square sine square phi. Now here I have made a slight mistake. Let me erase this. Here I was squaring equation 1, this equation 1. So if I square it, I'll get a1 square plus a2 square cos square phi plus 2a1 a2 cos phi. This is according to the formula of a plus b whole square. Now I am adding r square sine square theta plus cos square theta. I get over here on my LHS, and on my right hand side I have a1 square. Again I can take a2 square common from these two terms. So a2 square cos square phi plus sine square phi, and then I am left with this term 2a1 a2 cos phi. So you very well know this, that sine square theta plus cos square theta is 1. So I can write this as a1 square plus, similarly here cos square phi plus sine square phi is going to be 1. So my equation is reduced to this. So this is the expression for my resultant r. I can further reduce this expression like this. I take square root on the right hand side. Now you know this resultant r is a function of theta, rather cos theta. This term r will be maximum when cos theta is going to be 1. Now this is possible when theta is equal to m pi, where m is running from 0 to 1 to 3. So you can substitute here and get the value of theta. So r is going to be r max when cos theta is 1, so that r max will be equal to root a1 square plus a2 square plus 2a1 a2. If you carefully see, this is nothing but the expression of a1 plus a2 whole square. So here I get the expression for r max, the maximum intensity which the superimposed wave can have. Similarly, I can find out the expression of r minimum from here. Now r is equal to r minimum when cos theta is going to be 0. Theta will be 0 only when say your theta will take up the values like 2m plus 1 pi. If I am not wrong, you can recheck 2m minus 1 pi. Let me correct it. 2m minus 1 pi. Okay, and the m is running from 1 to 3 onwards. Similarly, I made a slight error here. Theta is going to be 2m pi, not m pi. Coming back to this expression of r minimum, I can utilize this expression to find out r minimum. Now we know cos theta is going to be minus 1. So r minimum is going to be a1 square plus a2 square minus 2a1 a2. So this is nothing but again the expression of a1 minus a2 whole square. So here I get that the minimum value of resultant can be the difference of the two amplitudes of the waves which superimposed. Here a1 and a2 are the values of amplitude of the two interfering waves. You can see over here. So the resultant which we get is reduced to this simple form. Thank you for watching my video.